Hello, my name is Daniel Rothman, and my team's project is the Arcade of Endless Adventures. In this project, we're going to talk about globalization, standards and considerations, feasibility analysis, risk analysis, plan of action, multidisciplinary aspects, personnel, budget, and project description and other deliverables, and the conclusion. In this section, we're going to talk about globalization and the standards considerations. Technology is constantly evolving and changing, and as it does, so does our way of living. Entertainment is one of those ever-changing aspects that people constantly crave that continues to grow and improve as time goes on. One aspect of entertainment is the video game industry. People all over the world, ranging from kids to adults, all play video games. The Arcade of Endless Adventures team is highly confident that the product will be well accepted into the global market. Our first contact is Fawn Al-Mzawi, a 24-year-old architecture student from Bahrain. We expressed the idea of the Arcade of Endless Adventures to her, and her opinions were all positive. She even mentioned as a child she was always interested in an off-brand video game console off away from Nintendo and something more affordable. She says that kids in Bahrain would be very accepting of our product's capabilities. Our next contact was Eleni Lenin-Quent, a 27-year-old citizen of Santo Domingo, Dominican Republic. Eleni showed great interest in the idea. She even has kids of her own who says that the product would make a great addition to their game nights or times with the family in general. She also expressed that video games nowadays are very single-player based and that this will bring together friends and families in a way that other games can't. Next, let's move on to standards considerations. Standard considerations are important to keep in mind when designing or manufacturing a new product, as it leads the charge for the product to be accepted into the global market. Different countries have different standards that need to be upheld. The National Fire Protection Association, NFPA, deals with ensuring that the product doesn't get in close proximity of flames. In any event where there is a flame, due to a short circuit of some sort, the fire needs to be eliminated. Next are the IEEE standards for wire and wireless communications. Our product is going to have both wireless and internet capabilities, opening the doors for things such as cyber attacks. These standards were developed for Bluetooth devices in order to manage the quality they can provide. These standards listed down below are the ones we plan to follow. Next are the IEEE standards for batteries. Our product is going to have both stationary and mobile capabilities, and the standards listed down below are going to ensure that the battery is safe for both those aspects. Next are the IEEE standards for computer technology. The standards listed below provide guidance that applies to planning, execution, and control of the maintenance process. The scope of these international standards includes maintenance for multiple software products with the same maintenance resources. They establish a common framework for software lifecycle processes that can be referenced by the software industry.
Greetings, my name is Omar Durder, and I will be presenting the feasibility analysis section of this slide. Now, the reason why this slide is very important is because it will show us how doable our project really is based on the measurements that I will illustrate here. So, as we can see here, we have a table. What the table does, it basically compares each feasibility analysis with the other. So, as we can see here, 1 being equal and 9 is being an extreme case, as we can see here. So, technical with technical obviously will give you a 1, as we can see here from the diagonal line. We have several feasibility analyses that we will take into account, such as technical, marketability, economic. As we can see here, I also have the numbers ranging from here on the slide. As we can see here, some of them are less than the other. We can see 1/3, 1, and 3, and a range of numbers in here. Next, we'll move on to a different table to get some calculations. Here, we can see is the table that will give us the G-mean with the weight. As we can see here, the G-mean is calculated by the rows. All the rows on one row multiplied by each other taken to the power of 1 over n rows. Now we can get the weight from the G-mean as seen in here. The weight is the G-mean value of the row divided by the total, as we can see here on the slide. Now we will move on to a very important part of the slide. This one here is a weighted table. What this basically does is it tells us how doable our project really is. For an actual doable project, a 3 and up is a very good score. So that's what we aimed at getting based on what we have measured. Before this, we have measured each feasibility analysis by itself, and we gave them a score of 1 through 5. Of course, 1 being the lowest, 5 being the highest. With all of this, we basically take the weights, the G-mean, and the W-score. We have calculated this, and we got a whopping value of 4.4. According to this, our project is very doable, as we have gotten above a 3. This is good news, but of course, we will still continue our professionalism and working on our project. This means we have to go to our next slide here. This slide is the risk analysis. Of course, everything in this world comes with risks involved. The risk can pertain from legal to any other kind of risk. What we plan to do is either minimize the risk or eliminate them completely. Now we will go on to our table. Is that we categorize each risk into several categories, 7 in particular in this case, such as technical, schedule, resource, economic, cultural, legal, and marketing, as we can see here in the future slides. Here we go, here's 3 of them. We divided it into 2 pages so we can see better. Here's the second part of it. Now, an example of this would be scheduling. Scheduling, the question may arise, are we going to get everything done in time? In particular in the break. Are we going to forget? Are we going to practice? This is a risk and it is a valid concern that our team has. This is just one example of the 13 possible risks that we have found. We also categorized them on the seriousness in the next slide, as we can see right here. We divided them into classes and categories here. Classes range from 1 through 4. 1 being, of course, above the threshold, nothing serious, nothing harmful. Class 2, it's on the threshold. Okay, eyebrows are raising. Class 3, below the threshold. Okay, time to look and see what's going on and maybe supervise a little bit. Class 4, very serious, heavy attention is needed, management is required on this case. We also categorize them in colors, as we can see here. Green being low risk, not too bad. Yellow, moderate or severe, with yellow and beige color, as we can see here. Also, we have the red color. Red color is catastrophic and needs serious attention. So we categorize them. We have them here in different classes. What's next is a plan of actions. So we have here all the actions that we plan to take per risk that we have categorized in here. So we have our plan of action. We have what we're going to do, how we're going to solve it. Another example we'll go back to, one action on the scheduling. Are we going to get stuff done on the break? Are we going to forget? Action here is, you know what, let's practice more on the break, more of our programming, and don't forget everything that we have learned in this class. Now, we will move on with Ricardo on the plan of action.
Hello, my name is Ricardo Garcia, and let's talk about the plan of action. So for any successful product or project, we need a successful plan of action. And with a plan of action is a sort of a game plan. And with this game plan, we can decide how the project is going to be separated into different phases. And within these phases are tasks that are designed to make a successful project. So from this chart, you can see that the project is split into 4 different phases. And each phase has a designated set of tasks, and some of those tasks depend on other tasks. As you can see here, from the research and planning, we have the conceptual work, the proposal, and the different hardware pieces that we'll be collecting for the project. For the touchscreen, we require the Raspberry Pi to be selected first because we need to figure out what touchscreens are compatible with it. Secondly, let's move on to the next phase, which is the software design. The software design phase will be creating the video game levels and developing the sprites and the backgrounds for these games. and also the orchestration software that will be coming along with it to deploy these games into the actual Raspberry Pi. The next phase is a hardware design phase. Here we'll be mounting the hardware that we collected in the first phase and testing that onto the actual hardware. And lastly is the testing and implementation phase. In this phase, we'll be testing the software on the actual hardware in unison, as well as make adjustments to the software. This will be a complete system test, end-to-end testing to be done. And finally, we'll reach our final prototype. Next, let's talk about the Gantt chart. The Gantt chart is very useful as it sets up what days and our deadline for creation of the project. The first part of the project, the research and planning, starts on February 1st of 2021 and will end March 30th, 2021. Here we'll be using a couple of weeks to get together the project, discuss the conceptual work, and collect the different hardware pieces that are required to complete the project. And also learning out the programming language that we've been chose for the project. Next, we'll be working on the hardware design. So from the hardware design, we'll be mounting the devices and testing the actual hardware. This will start March 25th, 2021, and be ending March 31st, 2021. We don't believe this will take long, 5 or 6 days at most. We can always adjust for anything that we need to do. Next is the software design. The software design starts 5 days after mounting the hardware and will require all team members to work in unison to create the game levels, the sprites and backgrounds, and then the construction of the orchestration software that we use to deploy these games onto the Raspberry Pi. And finally, after the project is at end phase, we're doing this testing implementation. As you can see, a lot of these phases overlap, and that's because they require different tasks and dependencies on the other phases. And the last testing implementation phase starts on June 20th and to the end of the project of August 30th. So here we're testing the software and hardware connections and make adjustments to the software where needed. Next, let's talk about the PERT chart. The PERT chart shows the dependencies of each task. In the first phase, the only dependency that we have is for the touchscreen for the Raspberry Pi, and really it comes up from the conceptual work of how we're going to put everything together in that first phase. The next phase, we just need the mounting of the devices and the testing. And then the following phase is the development of the video game levels, and from there we can construct the orchestration software to deploy these video game levels to the actual Raspberry Pi. And lastly, we need to make adjustments to the software after testing and rigorous weeks of making sure the software works on the actual hardware. We can create a complete project. This helps the team members figure out what is the next thing to do and why can't we move on to the next part, because we're requiring one more dependency or task to be completed. Thank you.
Greetings. Now we'll talk about the multidisciplinary aspect. This is less important because it will demonstrate each team member's knowledge and the skills and what they will contribute to this project. Now, as we can see, we have 5 team members. We have Omar Dardar, which is our team leader, and he will contribute networking skills and cybersecurity skills, which is what his concentration in. Daniel will also contribute skills in data systems, software, and telecommunication. That is his specialty. Abdius, he will have knowledge on cybersecurity and computer architecture. Mohammed Al-Madid will contribute to control systems and data system software. Ricardo Garcia will contribute to the computer science, and he will also contribute to the networking skills. Now, for our personnel, we'll contain with 5 personnel. Omar, he works in hospital, Jackson Memorial Hospital, and he is currently seeking a bachelor's degree in computer engineering. Daniel has experience in retailer, and he is looking for a degree in computer engineering, BS. Abdius, he currently is a math teacher, so he has all the knowledge or skills in mathematics, and he is looking for a bachelor's degree in computer engineering. Mohammed Al-Madid has many skills and experience, as currently seeking a bachelor's degree in electrical engineering. Ricardo Garcia, he is an integral component of our projects. He currently works at UKG as a software test engineer, and he is currently seeking a degree in computer engineering. So, he has all the necessary programming skills that we will need in this project. Overall, our team members here have a good skills in the programming and networking and the hardware skills that we'll need for this project, as it is composed mainly of programming. Here is our budget. Now, we calculate on budget in different way. Here we have it from Microsoft Excel. It was very simple for us to calculate it as much as the project consists of programming. So all what really needed to purchase was accessories and basic cabling, and what not we ended up getting surplus amount of money. We all put in money and added it all up beside on the median of what everything costs, and then we look for deals online, especially Amazon, and then we purchased all the whatever was necessary for our team. The reason why we did this is because always there is a problem, it may occur. So this is surplus money, we'll put it down toward anything that we may occur in the future. Maybe we need extra cabling, maybe we want to optimize this, maybe we want to optimize that, or coming with a newer idea. So overall, we'll be mainly programming, and we're self-funding team. So what are we doing? Just programming, and that's it. Mainly, we bought very little accessories and supplies that we'll use for this project. We'll just be programming, which is everything is free from PyGames and Python and the Raspberry Pi. The hours we didn't even put it in here because we're gonna working around the clock, so there's somewhat of salary typing. So this is our team, this is our project. Now we'll move to the next colleague, to the next part of the project.
Hi. Any successful product that is out there first started with an idea, a plan of execution, then prototypes are developed, and finally, when all parties agree to its final version, it is put out there in the real world. In this section, I'm going to talk in the next few slides about our video game consoles and its features. At its very basic form, our video game consoles can be played with the help of a mouse and a keyboard while it is connected to a display monitor with an HDMI cable. As you can see here, it is self-embedded with the internet. That's the very basic form of our video game. Next, instead of using a keyboard and a mouse to connect to the Raspberry Pi, it's a video game. You can use directly game controllers. These game controllers can be connected to the Raspberry Pi using HDMI cable or USB port. Also, instead of using an HDMI cable to connect the Raspberry Pi to your display monitor, you can also use an HDMI transmitter. The transmitter will mirror your game into any display like your TV, your computer screen with transmission, Wi-Fi transmission. Here, we take it even one step further. We can use a network attached storage so you can expand the number of video games that you can have available to this system. And finally, this gaming system can be either wireless or wired with the help of HDMI transmitter or using HDMI cable to make it wired. This is an absolutely unique gaming system.